In this video I want to talk about pressure and pressure units. This is the second part of pressure videos. So units of pressure. In SI system or metric system, the unit of force is a Newton, as you know, and we show it by capital N, which is the force, and F, required to produce an acceleration of 1 meter per second or per square second. So 1 meter per second square in a 1 kilogram mass. So as you know, F is equals to M times A. So F, or force, is a product of mass and acceleration. And the unit for acceleration is M over second square. And as you know, here in matrix system, the unit for mass is kilogram. A pressure of 1 Newton per square meter is defined as 1 Pascal. So as we said in last video, we said P is equal to force divided by surface area. So the main unit in SI system for pressure is Pascal. Pascal is equal to force in terms of Newton per area in terms of square meter. And since this Pascal is a very small unit, usually in SI system pressure is reported or shown by kilopascal, and 1 kilopascal is equivalent to 1000 Pascal. The pressure of a gas is usually measured indirectly by comparing it with a liquid pressure. Pressure of a liquid depends only on the height of the liquid column and the density of the liquid. Consider a liquid with density D contained in a cylinder with cross-sectional area of A, filled to a height of H. So we have the container has liquid, the density of liquid is D, we show it by D, and the cross-sectional area of this container is A, and the height of liquid in this container is H. So if you want to find the weight of this liquid, which is equivalent to force, it's gonna be M times G. So we said it's mass times acceleration, and since we are dealing with weight, it means that mass times gravitational acceleration, so M times G. So the volume of a cylinder, on the other hand, is the product of height times cross-sectional area, as we know. So the volume of liquid is height of the liquid times cross-sectional area of the container. So if we go back to the original definition of pressure, is P is equal to F over A. Force is weight, so if we have weight over A, weight is equal to, as we said, M times G, or G times M. M is mass, and we know mass is equal to volume times density. So it's going to be G times V times D. So V times D is equivalent to mass. Again, volume times density is going to give us mass. So divided by A, and V here, the volume of liquid, is the product of height of the liquid and the cross-sectional area of the container, as we had it here. V is equal to H times A. So we can substitute here. So here we have G times H times A times D. So these A and A cancel each other, and the result will be G times H times D. Again, G is gravitational acceleration, which is constant. H is the height of liquid in the container, and D is the density of liquid. So liquid pressure is directly proportional to the liquid density and the height of liquid column. So it means that when we increase the height of liquid, the pressure is going to be higher. Or if we use a liquid with higher density, pressure is increasing. So as we see here, we have some interconnected containers with the same height of the liquid, or liquid height, and we have the same liquid inside. So height and density are equal for all these columns. So since we have same density and same height, we can say that the liquid pressure for all these containers are equal. no matter what shape we have in this picture. So for all these containers, we have the same liquid pressure. That's why we have the same height in this example.